Hi there, I'm Ustun and today I'm going to talk about taming complexity with Django. So I'm a developer at Sellercraft, which is a social networking platform for the advertising business, and I lead the development there. And today I'm going to be sharing my experiences, or as Oscar Wilde says, my mistakes that I have made so that you can avoid them in the future. Now this talk was actually inspired by another one, a talk given by Richiki in Strange Loop in 2011. In case you don't know, Richiki is the creator of the Clojure language, a functional list running on the JVM. And in this talk, he compared simple and easy, those two words which we conflate all the time. He said that we are infatuated with easiness and benefits, whereas we ignore simplicity and trade-offs of our constructs most of the time. He emphasized that complexity is actually the single major difficulty of successful development of large-scale software systems. Now the dictionary definition of complex is first consisting of many different and connected parts, not easy to analyze and understand. The second definition is a group or system of different things that are linked in a close or complicated way. Now, I'm sure that this sounds familiar to most of you, right? But is there a way out of the tar pit? Now, in this talk, Richiki emphasized simplicity as a way to avoid the tar pit. When I first watched this talk, my reaction as a Django developer was first admiration and some kind of enlightenment, which was immediately followed by some kind of uneasiness and insecurity. The reason was, most of the examples he gave there was, objects are complex, values are simple. ORMs are complex, whereas SQL or data log are simple. So if there's a way out of the tar pit for most developers, maybe Clojure ones, is there a way out for us Django developers? I didn't know why. So my answer to that is an emphatic yes, hopefully yes. I believe that in Django's spectrum, which extends from simple websites to intermediate level business projects, Django excels, and it is not only easy, but it is also simple. The reason is that it partitions the domain web into loosely coupled and a few concepts. Also, I came across this word habitability in Richard Gabriel's Patterns of Software book. Richard Gabriel is a common Lisp hacker, famous common Lisp hacker, and he defines habitability as characteristics of source code that enables programmers, coders, bug fixers, and people coming to the code later in his life to understand its construction and intentions and to change it. Now, if you read this definition, I think Python and Django excel at this. You can immediately go to another Django project and be productive in it very easily. Now, before we understand complexity, let's dissect it. So the first part of complexity is what we call essential complexity. Essential complexity is basically the complexity that is due to the domain. And the most significant complexity of many applications is not technical. Now, if you do not understand the problem you are solving, no amount of coding can save you. So the main reason is that business logic for us developers is mostly like military intelligence, two words that do not make sense, an oxymoron almost. Most talented developers do not have much interest in learning about the specific domain they are working in. Technical people enjoy quantifiable technical problems that exercise their technical skills. The domain is messy and demands a lot of complicated new knowledge that doesn't seem to develop a computer scientist's capabilities. Complexity in the heart of software has to be tackled head-on. To not have this is a project risk. These are quotes from a book Eric Evans wrote in 2003 called Domain-Driven Design. In this book, Eric Evans emphasizes that the primary focus should be on the domain and domain logic. Complex domain designs should be based on a model. He emphasizes that we should form a common, ubiquitous language with the domain experts. So when we look at the design spectrum, in the olden times we had waterfall, where there were the domain experts, analysts, architects, and finally the poor coders. Whereas Agile was a response to this, which got rid of all the intermediaries. Now I believe domain-driven tries to find the middle ground so that you can communicate directly to business people, not through intermediaries, so that you have a tight feedback loop. Another advice he gives is, you need to write it down. As Les Lamport of Distributed Systems fame has told us, everyone thinks they think, but if you don't write down your thoughts, you are fooling yourself. The main reason is that actually humans need to analyze processes, but they are bad at analyzing processes that extend over time. By writing it down, we basically freeze it over in time, and so that we can analyze our thoughts statically. And if writing doesn't cut it, you can always graph it by hand, Graphies, OmniGraphil, whiteboard, whatever. Now let's move on to accidental complexity. Let's see how Django helps us here. The first line of defense is apps. I think apps are one of the major strengths of Django projects. It's almost like Django invented microsystems 10 years ago before they were cool. So what an app does is, through URLs, you form a boundary with the external world. And through models, you form boundaries with inside. One problem here is that you should not be misled by the code or organization. That is, putting simply different things in different folders will not help you if you don't untangle the complexity between your apps. Second line of defense, models and managers. So, you need to understand the patterns Django uses. Django uses active record pattern for models, repository pattern for the managers. These are outlined very well in Martin Fowler's Patterns of Enterprise Application Architecture book. If you haven't read that, check it out. So the basic idea is, as we all know, you should move stuff away from views as much as possible. Put all your business logic in models, managers, or some closely related abstractions like namespaces, objects, or even functions. You need to minimize your views, but also use forms so that your application is not only correct, but it is also robust. Now, one thing when you follow this advice is that you will, in time, gain fat classes. So, what do we do in that case? Here are some solutions Python or Django in particular provides us. First line of defense is mixins, which are multiple inheritance. Second, we can use composition. And third, functions and namespaces. Also, one trick you can pull is you can form a modules package instead of a models module, so that every model lives in a separate file. But again, do not be fooled by file organization. If you just simply put your different models in different files, you might still have a complexity, untangled complexity. For mixins, let's consider the simple case where we have a fat model with 7 different models. Now, in a case like this, the first thing you should do is see if you can group different methods into some reasonable abstraction layer. So, for example, in this case, I have grouped the first 3 methods in aspect 1. When I say aspect, I don't mean aspect in the aspect-oriented sense, but just like an aspect or function, a functional interface. So we have aspect 2, aspect 3, and then we simply mix in those to our models. You can not only do this with methods, you can also mix in fields. So you can, for example, if you are dealing with date created, date updated, you can abstract that out as a mixin and mix in those to your model classes. But over time, as you'll see, aspect 2's methods can very easily call aspect 1's methods, and you will again face the problem of those entanglement. Instead, you might consider preferring composition to make boundaries explicit. So in this case, one additional thing I have done is I have marked 2 methods as private. So method 3 is the public interface of aspect 1, and in the right-hand side, during the initialization method, I simply inject those as components into my model. Now, cyclic dependencies is again a problem, and cyclic dependencies are very easy to create in object-oriented programming. Like, think of a person class with an address class, and in address class you want the residence, right? Person is tightly bound to address, whereas address is bound to person class. Now, in order to avoid this, you can put imports inside the method calls sometimes, but it's like sweeping dust under the carpet, and if you see this pattern all the time, simply use functions or objects containing different namespaces. So if you want a pattern name for this, this is the service pattern. And you always try to prefer trees instead of cycles. Also, as I said before, sometimes functions in namespaces are the solution when it is not clear to which model a function should be bound as a method. So in this case, we have the person, company, and we are trying to bind two different methods, but maybe those two methods get as argument a person and a company. Now, if it doesn't belong to either of them, you can simply move them out into a separate namespace and call a simple function. And when you are calling, you can call it from the namespace. So you are using namespaces as a bag of methods. And when all fails, always remember that data is greater than code. Sometimes no code is the best code. So you can use data to represent state machine states, and data is easier to manipulate and visualize than code. So, for example, recently we needed to implement a registration in our user registration and customer registration in our project. And instead of coding, I started with this. Now, in this sketch, you'll see all those markers, right? If I had first done coding, then I would have to refactor it. But simply I grabbed my pen and drew over those. Once I had this structure, this graph in my hand, I simply translated it as a simple data model. It's a simple dictionary. So basically, each state has a description, each state responds to some transitions with some event names, and what's more, I was then able to plot this using GraphViz so that I could show it to my client, so that we could check it all together. In fact, when I came here, I met two awesome Norwegian guys who are using a similar Erland and Bjorn's rule-based system. So they shared their state model with me, and they told me that they are actually going over with the customer using this so that they can check their business logic is fine. And if customer says, oh no, you shouldn't go to left, you should go to right, they can immediately fix that with no code changes. Now, the third layer of abstraction Django provides is a template layer, which is also the weakest point of Django in terms of abstractions. Django has been pretty much agnostic in this case, so its extents and includes are primitive, called scope help. Because a child component can basically see all the scope of the parent components. Now in this case, if you are going to go with Django, simply prefer template tags or even better inclusion tags. Inclusion tags have a horrible name. They should have just been named components, and they start with a clean context by default, as it should have been. However, today's complex applications have demanding UI requirements. In fact, Christopher said that there are two major problems in computer science. I think there are three. So the first one is caching validation, the second one is naming things, the third one is off by one, and fourth one is building UIs. Building UIs is hard, especially for us server-side developers. Now, server-side UI development is easier than client-side, and why is that? Is it JavaScript's fault? Everyone tries to mock JavaScript, that weird language. Have you seen the bottle where he compares one to empty array and somehow gets a true in the end? But actually, Douglas Crawford has shown that JavaScript is actually list in C's clothing. So learn JavaScript and embrace the fact that JavaScript, as long as it is a problem, it is not the problem. If JavaScript is not the problem, what is the problem? Building UIs is hard because there's too much state. And state changing over time is the root of all evil, in the words of Python, a developer at Facebook. State changing over time is the root of evil. Take that, Knut. So, server-side versus client-side. Server-side UI has 0 lifetime. I mean, it has all those rendering times, etc., but essentially it has 0 lifetime. Whereas client UI has much longer lifetime. You send the application to the client, The application starts, user interacts with it, callbacks are executed, and guess what? Your UI is still alive and kicking. And there are too many lifecycle changes. And you cannot grab hold of those lifecycle changes without controlling state. Now, wouldn't it be better if we could discard the current UI and render from scratch? Now, this is actually why server-side rendering works, because it always starts from scratch. There is no state in Django. This is what we do when we refresh the page, when we redirect the page, so that the user can start from scratch. Now, if we had a tool that handles diffing and patching for us, so that we can concentrate on the essential complexity, we can concentrate on handling the state in our UI models, wouldn't it be better if our UIs were a composition of smaller, isolated components, much as like we can reason about our objects or functions or namespace in our Python code? However, we cannot abstract that in our UI. Wouldn't it be better if we had a tool so that we can divide and conquer, we can reason about, and actually we can get along with our designers, because that's basically the way they think about UI. Introducing React.js. So React.js is a solution to these problems. It was developed at Facebook, has been in production use for the last 2 years, battle tested, and when Instagram was acquired by Facebook, they did not have a website. And guess what? When Instagram wanted to build, they saw this awesome technology in Facebook and said, we want to use that. So Facebook extracted that technology and open sourced it last year. So it's currently in the whole UI in Instagram is built using React. Facebook's command system uses React, and Khan Academy switched to React, and Python, Jordan Wald, Paul O'Shaughnessy, Sebastian Mark-Page, Christopher Chodo, and Ben Alpert, these are the main developers of React. Now, in 5 minutes, I'm going to make each and every one of you React developers, hopefully. So let's start. In React, everything is a component. It's very simple. Everything conforms to the contract that it has to have a render method. Now you'll see that I'm actually returning a simple div here. Div hello Django world EU, close a div. Now this is actually a JavaScript dialect Facebook wrote called JSX, which internally changes that div call to a function call. But you are completely shielded from that. So you get, for example, your HTML from your designer. Just inject it there. It will work. Finally, you'll have an empty container in your page. You just need to render the top header, top component by calling React render component, and there we have our first React component. Now, since you are Python developers, you don't like curly braces that much, so I have invented a new language called JavaScript with JSX power. So you'll see that I have gotten rid of curly braces, used indentation, and hopefully you can understand what's going on because I will use these in my next slides. Now, when a designer gives you a template, they don't think about on the left, they think about right. So first, you should dissect your UI into components as outlined in the border on the right. Second rule of React, components can have other components as children, much like in composition in Python. So let's build a greetings component that displays two of those hello world components. It's very simple. We just have a render method that returns a div that has those two children elements initialized automatically by React. And in this case, we just mount the author component, which is called the owner component. And all the children initialization is done automatically by React. All the children destruction is also done by React. Rule number 3. Owners pass data to children through properties called props. Props are basically attributes. So in this example, I have appended those bolded. Greeting equals hello and greeting equals merhaba. Okay? Now you'll see that the output is completely the same because we are not actually making use of that. So rule number 4, components can use props during rendering. So here we have a curly brace, this props.greeting instead of hello from the previous slides. So it has two curly braces less than Django template, so it's more efficient. But in the end, we have a greetings component where we can pass some attributes, and in the end, we have a reusable component. Hello Django EU, bienvenue Django EU, and merhaba Django EU. Rule number 5. We have passed props, but some components, not all, in fact very few components, need to have state. And you need to make state changes are explicit. As I said before, you need to handle state. You need to take control of it. If you don't take control of your state will take control of you. I'm sure that must have made Bakunin and Proudhon proud. So, now what has changed here? Let's implement a counter component this time, okay? Now, first, always start with the render. Always start with the render. Start with a simple HTML and grow from there. In render, this time I'm saying you click me, this dot counter times, okay? So, where do I get my initial state? Okay, in order to handle state, I need to control two aspects, the initial case and transitions, right? Simple as that. Initial state is just an object, counter is 0, okay? If you want to start it from 10, just write 10 there. Now, the thing is, I made an on-click handler, which we'll call this.handleClick. In this case, this refers to the component itself. It will call handleClick, and guess what handleClick does? It calls setState with a counter incremented by 1. Now, the trick here is, it doesn't do counter equals counter plus 1. This is the major problem of most languages where you have mutable variables. In JavaScript, we have mutable variables, but React is somehow sort of through the distinction of props and state mitigated. And all the state changes in React are through the setState call. Using that, React can know that it should re-render, so that you never call render yourselves. If you hadn't used a setState setter like this, you would need to wait until object observe, or you need to do dirty checking like Angular, which is painfully slow. So in this case, the component is initialized with you click me 0 times, and when I click it, it automatically transitions to the state you click me 1 time. Now I will go back a little and say that keep shared state at the top. Now we had our counter having state, right? In React philosophy, you need to minimize state. You need to minimize state and lift it out. All the state should live as top as possible. Okay? So let's say I will have two counters in this case. One will be a forward counter and the second will be a reverse counter. Okay? Now when I click the first one, I want the second one to be decremented. So the first one will go from 0 to 10, and the second one will go from 10 to 0. Now the good thing with React is you need to think about the minimal state your application requires. Let's think together. In this case, counter component, no state. Reverse counter component, again no state. Only the counters component, that is the parent state, has a state variable called counter. So simply changing the counter variable, counter the state variable in the parent component will transition me automatically to the next values of the system. So the way it works is basically the owner passes the data downwards, okay? But the child has to have a way of responding back. So just like a boomerang, the owner sends the data, the child needs to inform the parent that something has happened, do something for me, okay? The child is never responsible for handling the state. The child just, like a boomerang, sends whatever it was called back. Now, 6b, children, again, this is already explained, but let's go over this. Now this time, I am binding the onClick handler not to my local method, but to a method that is passed in a prop. Okay? So instead of onClick this.increment, I say this.props.increment. So I say, whenever I am clicked, do not call the increment method on me, call the increment method whatever has been passed to me. Again, reverse counter is the same. You see that is almost exactly the same. Now the counters component is where the complexity lies here. So you'll see that it passes props counter, increment counter in both cases. It has a simple get initial state. It has a simple increment counter, which I have borrowed from my previous single component design. So in React.js, we have isolated components, explicitly managed state, unidirectional data flow, UI reacts to application state changes, children are automatically rendered, and you have the full strength of programming with JS. In my examples, render immediately return, but actually you can do stuff in render, except of course changing the state. And most importantly, you do this without sacrificing design-driven development, that is, I mean in the UI sense. So I believe that React.js is a best fit for Django. I won't say the, but I think it's the. So it's the easiest to adapt for a server-side developer. As you can see, I have almost shown all the concept of React in those minutes. It's very conceptually similar. To see why, consider the following reason. Templates are not actually HTML. Templates are actual functions. Data comes in, it passes through a function, a UI is generated. So let's compare Django and React rendering. Django, views prepare the data, passes to templates, render method. In React, the main method is again a render method. It prepares the presentation data using the application data. It passes it to children, which are also, in turn, another function. Now, you might say, this is actually true for other templates, like handlebars, for example, compiles down to function, right? But what is exactly different about React is the render method in React defines your UI at any point in time. Django defines your UI at time 0, and that leaves you. In React, you can see how your UI is going to be represented just by inspecting the render method. Other benefits, it's very fast. Since it doesn't do dirty tricks like dirty checking, it's very fast. And one of the common complaints in client-side UI development is that now you have gotten rid of those server-side rendering, and then the user has to download a bunch of JavaScript just to be able to see a single tweet. So this problem is known as the time to first tweet. And in fact, Twitter switched to server-side rendering after implementing client-side rendering. One of the problems is SEO. Google says that we scrape your JavaScript applications, but we do not know how much weight they give to them. So the solution is to you can build your UI server-side and make it alive on client-side, thanks to React's virtual DOM. React does all of these things without interacting with DOM directly. It actually has an abstraction layer called virtual DOM, so that, in fact, instead of rendering to browser DOM, you can render to simple HTML scripts, HTML strings. So let's see how it works. Django View prepares the data. You have another Node.js component renderer, a server running. Django sends the raw data React component renderer. An HTML string is returned. In your Django template, you embed the raw data, both the raw data and the generated HTML. Now, user receives the full page with full HTML. Then React comes to action. Since it knows both the string and both the raw data, it can do a checksum. If it matches, it simply binds to the event handlers. If it doesn't match, state wins. React discards your UI, generates again a win-win, and user now has an interactive page. So in summary, complexity can be managed in Django since it provides solid foundations. UI layer, however, is problematic, but React is to the rescue. And I would like to also mention another project called Reactive.js. This is by The Guardian, so also check that out. Finally, I would like to thank you to Django and React teams for making our lives easier. Thank you, Damla, my wife, for her proofreading and encouragement. Thank you, Mom, for encouragement. Thank you, conference organizers, and thank you all for listening. I hope you are all Django and React developers by now. Thank you.